Good afternoon. Good afternoon, everyone.
Good afternoon.
We hope you had a great summer and that you had the opportunity to take a bit of rest before that last straight line towards the end of 2024. And today, as you know, we will be talking about alternative fuels, so all type of fuels. I will come back on the agenda. Before that, just to share with you the information on the following webinar, because it has already been decided. We'll be talking about Middle East and everything that is happening in that region of the world. And the date, as you can see, 31st of October, will be just before ADIPEC. I guess most of you will join. If you do join, don't hesitate to come back and visit us. We'll be, as usual, on the French pavilion, just next to the coffee machine. So we'll be pleased to welcome you on our booth. You will receive anyway the invitation for this next webinar, and you will also receive the slides of today's webinar. So don't bother taking any screenshots. The agenda of today that we'll be discussing first, we'll start with some news, mostly about To Be First Consulting that we want to share with you. And then we'll deep dive on the subject. First, the definition of all the alternative fuels, which is bio, e-fuel, syn-fuel, renewables, what is behind, what is their market, what is their usage, and then what it means in terms of processes and project. And finally, before the conclusion, we will also have a look at the key players on this specific project. If you have any question, don't hesitate to ask them within the chat. We will just address them at the end of the presentation. So as the subject is quite tough today, I suggest that we start right away with some news. Jean, if you can share with us the good news that we wanted to have today.
Sure. Thank you, Jack. And thank you, everyone, for joining us today. I'm sure you are quite busy in this beginning of, I would say, the scholar year. But we just wanted to share some piece of news. You may have seen during this summer that we have been working quite massively. We changed our logo, we changed our design, and that's not the only thing we changed, to be honest, because we try to change a little bit the definition of our company, because some of you only see us sometimes through the data and through Project Smart Explorer, but it's a little bit more than that. And if you are joining today the webinar, I'm sure you experience that it's not only a database. There are people behind, and we are moving more and more to become a company which is an energy knowledge center. That's our focus, our target. And putting you in the middle, it has today, I would say, three branches. The first one is still Project Smart Explorer with all its data, information about project, report that you may have received also this summer. But we want to explore two other reports, the expertise one where you are used to the webinars, to the workshop, and also the outline that you can click at any time. And we have created in the last few weeks a third branch, networking, I would say, a branch. The idea is to explore not only our network, but the network of our customers, and see how we can make customers work together. So we had a first, I would say, test with the French colleagues. It works very well. So we are going to repeat this exercise in all the region of the world to make sure that we all know each other and we can all support each other in getting more projects. So just have in mind more and more that it's not only Project Smart Explorer, okay? All those services are open to you to make sure that you gain control of energy project and you gain more orders at the end of the day. Another, I would say, evolution of the company, which will start today, is the scope. You may have seen that we started 12 years ago only by oil and gas, petrochem, that we start to increase the scope to include all energy transition. And in fact, during the summer, we have worked to introduce also all the mining project and the geothermal project. So starting tomorrow, you will start to receive also news about mining project and geothermal. So it will grow, I think, till Christmas about those projects. We have made the models. If you have any feedback regarding our estimation, feel free to come back to us. But the idea will be to have all the projects of the energy world, energy being a really broad scope today, all in one database, to make sure that you can go on all the trends that are interesting to you. So when we say mining, when we say geothermal, what does it mean? Here I put you 2 slides to explain that in more details, but just to pass quick on the topic, the idea is to categorize all the mining depending, of course, on the raw material you're going to try to collect. So of course the metallic, the non-metallic, and the rare earths, which are becoming more and more, I would say, a hot topic today. Location, it can be surface, under the ground or offshore. We'll look over it. And in terms of type of plant, we'll have, I would say, the plants which are fully integrated from really the raw extraction to the refining, but we'll have also all the units in between to make sure that if there is a revamp about a mining project, of course, it will be part of the database with the right model. Same story for the geothermal. It can be to power or to produce electricity or to produce heat. We'll have it all. And the idea is you see between open loop and closed loop, or if it's a heat pump or power generation, etc. We'll have all the details of every model to make sure that our estimation of your product line and your service are always quite accurate. So you will start to receive those news. If you have any question regarding the scope, feel free to come back to us. If you have any feedback regarding those estimation and those information, feel free also to come back to us. It will grow, of course, and by the time we'll get maybe some maturity, so it will be our pleasure. Enough about those news. It's already quite a lot. As you can imagine, we have been quite busy this summer doing that. But like you, okay, we like to take that time, which is a little bit a slowdown, to work on our internal topics. Now going to the topic of alternative fuel, because that's, I would say, the game for today. The idea was to say, okay, it's really a hot topic. We hear it a lot. We see it in the news everywhere, but we hear a lot of, I would say, mistakes about it, and a lot of, I would say, approximation about this market. So what we really wanted to do first is to put, I would say, lay down the definition and what is behind those alternative fuel, because people can sometimes confuse. And in fact, there is 3, or let's say 4 words, wording that we hear a lot about those alternative fuel. And here they are: biofuel, e-fuel, syn-fuel, and renewable fuel. And while some are really quite different categories, it's not completely exclusive. Okay, some are part of the others, etc. So we try to put a definition. For biofuel, usually it's quite well understood. It's a fuel that is a derivative from biological waste. The first example that comes to mind usually is a farming waste or plants, if you cut your grass, that you're going to produce methane from. Those fuels are quite great because they have a negative carbon footprint, because usually if you leave those wastes to perish, I would say in the air, they will transform to methane. So just by transforming them into CO2, you are reducing the carbon footprint. The main example are, of course, biodiesel, biogas, bioethanol that we can see popping up everywhere, especially in US and in Europe. It's quite well understood. Then it starts to get a little bit more tricky when we talk about the e-fuel, because e-fuel, in fact, is a synthetic fuel. So here we start to put, I would say, a hand into the next category, and it's a fuel that is produced usually by capturing CO2 or captured CO2 from industrial waste, and you are going to inject green hydrogen, normally, and let's hope so, to produce all kind of fuel. And here, the carbon footprint is neutral, of course, if you are using green hydrogen. If you are using blue hydrogen, it's quite neutral as well. But if you are using gray hydrogen, okay, it has no chance, I would say, or no advantage in terms of carbon footprint. The most well-known are, of course, e-methanol and e-diesel that we start to see everywhere. The third category is syn-fuel, and here it's a category that is based on I would say, another fossil energy. Most of the case, you're starting to, I would say, as a basic from coal, most of the time, or from gas, and you are going to make it fuel. Okay, so you are changing the state of the carbon, more or less. Let's hope so, in a way, you are using renewable energy or renewable electricity at least. And here the fuel have, I would say, positive carbon footprint, but they are really good quality fuel. It really popped up many years ago, 10, 15 years ago, for those who are into cars, when Audi developed a Syn-fuel of diesel to win at Le Mans. race. So that was really the first use case that was developed, and now we start to see them everywhere. And usually when you hear about syn-fuel, okay, you hear a lot about this Fischer-Tropsch fuel and process that we will explain in a minute. And that's the last category, which is here renewable fuel, which is more or less encompass all the previous categories. So biofuels, e-fuel, and syn-fuels can be produced from everything: fat, grease, oil, CO2, whatever, I would say carbon. The idea is just to have a neutral carbon footprint. So here we're already on wording, which is kind of another layer between all those fuel, because of course you can produce e-fuel in a really, I would say, dirty way, and it's then not a renewable fuel. Renewable fuel means that you are producing one of those three, but you are trying as much as possible to reduce the carbon footprint. So in most of the case, using renewable electricity to produce green hydrogen and reject this hydrogen molecule with a carbon molecule. I hope it's, I would say it's a high level definition. Okay, we can go in the details of everything picky, but okay, we won't have enough time with this hour to do it. But I think it's quite interesting to take two examples to discuss it. Two examples that you have heard a lot of, I'm sure, and which are quite pragmatic because we are already using them. The first one is the e-ethanol. Which is a direct recycling of CO2 and H2, because ethanol is only two atoms of carbon and an atom of oxygen with the addition of hydrogen. And I say we're already using it because in North America and in Europe and also in South America, you can start to see it, which comes in addition, I would say, in mix with gasoline. In Europe, it's called E85. In US, I think it's called super ethanol. So that's a kind of fuel which is already used also in not only in the road transportation, but also in the maritime transportation. And it can be used as a fuel, but can be used also as a feedstock for petrochem to produce plastic, to produce other type of product. And the good part is that when it's produced through a clean process, mostly using green hydrogen today, you can reduce this volume of emission by 80% compared to, I would say, normal ethanol. So it's quite interesting. It's quite massive in terms of carbon footprint. Today, we are not at this size, I would say, to replace everything, but by starting to combine it with other fuel, of course, you can reduce drastically the emission of other fuel that are mixed with. The second fuel, which is quite trendy, is the sustainable aviation fuel, which is jet fuel, I would say, standard jet fuel. And here, the goal is to decarbonate the airline industry. And in fact, this solution can reduce the emission by 80%. So it's quite massive when you think about it. And it's not completely new because more than 500,000 flights have been powered by SAF since 2011. So it's quite massive when you think about it. We start to have a good historical information about those projects. And today, for most of, I would say, the flight where it's tested as a blend. Okay, so it's mixed with, I would say, normal fossil jet fuel. But I know that Airbus has made its first flight 100% SAF, I would say, so completely carbon free, and it's quite interesting to see how fast those projects are developing, knowing that they can use any type of feedstock, which is more or less agricultural, plant, or animal. So I'm sure those examples normally ring a bell into your mind. Maybe not into your business of project yet, but be sure that it will come. Now, in terms of market and usage, okay, it's good to say that it's happening, but how much it's happening, etc., and what are really the use cases behind can be a question mark for you. And in fact, when you think about the usage of those e-fuel, in fact, it's quite an efficient answer to climate change because you can really reduce carbon emission massively, if not being neutral, sometimes even be negative. So, I mean, it's quite a powerful tool if you think about it on the whole, I would say, life cycle of the carbon. And the idea behind it is quite simple. Today we produce fossil fuel, I would say, and we extract the carbon from the ground, then we use it and it goes to the emission. And here the idea is, as soon as this fossil fuel is produced, is to reuse it once, reuse the carbon molecule and close at least once the loop of carbon. And here you can imagine that it's quite virtuous in terms of idea. It works very well because that's less production that you are going to have at the end of the day. And behind the real idea is to use the carbon molecule as a vector of energy and reuse this molecule as much as possible before going to emission, and at least try to avoid those emissions. It's also a good solution, especially if you're in Europe, where the sovereignty of the energy is becoming quite a big issue, that you can reduce your dependency on imports from Middle East, from Russia, from US as well, by reusing your, I would say, carbon molecule that you already have. And to do so, you need to create jobs, to produce biogas, to produce e-methanol, etc. So you can recreate value and job in your ground while also reducing your importation from other continents. So as a lot of political people are looking for this kind of subject, it can be quite interesting. And you will see in the next slide that it has a lot of, I would say, political interest. The last part, which is quite interesting with those e-fuel, is acceptance, because I mean, energy transition is not always, I would say, a piece of cake, and people are sometimes quite frustrated about energy transition. And to be clear, not everything can become electric, especially if we talk about transportation. And here, it's a good solution that will require almost little or to no adaptation to the existing system of energy that we have in terms of distribution or transportation of energy, or even usage of energy, because the motors can use can work on the same way with e-fuel or normal fuel. So it's quite interesting to see that it requires little adaptation only on the production side. One figure that I wanted to share with you as well is a comparison in terms of carbon footprint. If you have here in yellow the carbon footprint for diesel, for gasoline, and here e-diesel, depending the way you are producing it. But you can see that the impact in terms of emission is completely massive. Of course, it has a down part. The price is more or less the double. Okay. And of course, you see in blue that the required energy to produce this fuel is quite massive, between 5 to 10 times higher than, I would say, fossil diesel and fossil gasoline. Which means that this, I would say, decrease in terms of carbon footprint has to be compensated by an increase in money, in cost, and an increase in energy spending. So again, a little bit like green hydrogen, it makes a lot of sense to save the planet, but only if you are using clean electricity or clean energy to produce it. Just one point, because it might appear about the price. The price is more or less double if you are comparing diesel with e-diesel. So you might say, okay, it's super expensive, it will never work. But in France, like we are today, or in other regions, usually when you look at the price of gasoline at the station, more than half of the price goes to tax. So it means that within the price that you have with tax, you could produce gasoline and e-diesel. So one of, I would say, the way out that producers are trying to push to political people is to say, yeah, we can push this to the market, make it profitable, and make people change to diesel and e-gasoline, but you just need to reduce the tax on the gasoline. It's a big, I would say, question. Not sure if anybody has the answer to that, but that's a way out that we could, I would say, inject e-fuel quite actively and quite quickly on the market at a low price. Now, if you look at, I would say, some piece of news about this e-fuel, you can see that it's attracting interest from all over the planet and all over all different type of actors. Of course, European Union, you might remember, say that, okay, they will stop all thermal engine by 2030. The only problem that they are not sure how to do it. So European Union is, I would say, moving back on this decision and evaluating to integrate the e-fuel into the law to say, okay, either you will use thermal engine working on e-fuel or you will use electrical car. And of course, I put both in parallel because you see that here the brand Porsche is investing millions and it's already active, so it's an investment to produce e-fuel for their cars because it seems that the client from Porsche are not so kind into only driving electric cars. No, it's true all over the planet. ExxonMobil is investing massively into renewable diesel. US is one of the biggest countries for those kind of e-fuel. Chinese are investing especially on SAF, a little bit like India. It's a little bit less true in Middle East. We see less traction for those alternative fuel in Middle East right now, but I'm sure it will come. And this example, when Saudi Aramco is starting to talk on the topic, they put big money on the table. Even for Brazil, it's a big question. And it's a big question also for actors and users of those alternative fuel. We are traveling a lot. And when you take plane ticket with Lufthansa today, they propose you to add a 5% increase to your fare for the ticket, but they will compensate between 10 to 20% your flight with SAF in a way to reduce your carbon footprint and I would say to help your corporation reduce its carbon footprint. So you see it's arriving to the market through those companies, which is also quite interesting. Now, if we look at the demand for those alternative fuel, I took two examples, then I will explain, but there is, I would say, a start for those alternative fuel in 2022, and that's when we start to see also project popping up. In this energy transition, when it starts, to be honest, quite after COVID, when we start to see the first boom. The first boom in 2020 was renewable electricity. So it was windmill, it was solar, it was electrical battery. Then the following year, 2021, we start to see hydrogen and carbon capture. So really more decarbonation project. And it arrived in 2022 when you had renewable and green hydrogen. People say, hey, let's put that together and say, what can we do with it? With this carbon that we have captured, we can make e-fuel. So that's why the growth of those projects really happened, and this boom really happened in 2022. And you see that we are increasing, and there is, I would say, a phase 2 period after 2035. So it means that today, if you are looking on the left, you see the shipping need for e-fuel and biofuel, and I would say all those alternative fuel. So you see that the shipping industry is using different type of fuel, but you see a big jump for 2035. Why? Because everyone is seeing, of course, this wall in 2050 of net zero, and you need to be, I would say, engaging into the industrial scale more or less in 2035. So that's why 2035 is really the path from one phase to another, which is more or less the same situation for the, I would say, aviation, where till 2035 it's a ramp up, which is quite lean, and then it's an explosion of the market, knowing that here it's written in percentage of fuel mix. Meaning that we will still have a base of, I would say, fossil fuel, but a big part of this fuel will start to be, I would say, a recycling fuel. If we look in the detail of those two examples, if we look, for example, the airline industry, in fact, when you need to, we all know that airline, I would say aviation is a big contributor to CO2. And if you look at the new generation, there is quite a boycott around the plane. It's not true everywhere because every year we hit new record of passenger around the planet. But anyway, the spirit is not good, and I would say the vision is not good. So they are really active into their decarbonation. And to be honest, they have little solution outside of the sustainable aviation fuel. Electrical plane are too heavy, so they just don't fly. And at some point, they were a lot exploring the hydrogen fuel. But the problem that if you want to have the density of energy to make a flight from Paris to New York, you need this hydrogen to be liquid. And for some of you which are experts in hydrogen, as soon as it becomes liquid, it's a nightmare because the temperature are high, the pressure are high, it's super thin, so leakage are a nightmare, and the risk associated to this liquid hydrogen is massive. So it's not really, I would say, practical to handle. Also, one of the last issue is that the only company which was working on the turbine of hydrogen was Safran, and this company stopped their program of hydrogen engine, so it will be hard to equip any company with that. So really, SAF is, I would say, the only way out. Airlines have to become carbon neutral, and of course, political like the European Union are super aggressive into targeting those airlines with emission reduction and putting a lot of fine onto those companies. So it's really the airline companies like Air France, like Delta, like or the one we know like Emirates, which are driving projects, are pressing, I would say, their suppliers of jet fuel to make this move. And airlines are more and more keen to push this increase in price to passengers. It's already the case, as I say, with Lufthansa, but it will come with all the others at some point, because starting in 2030, they will start to have big targets on reduction. So it won't be, I would say, an option. It will be mandatory to take this SAF option. So it's already possible. And just to give you an idea, I mean, we're talking about a demand of 600 million tons per year in 2050. The curve will more or less look like this. So you see it's increasing, and then you start to have a ramp up in 2035. So till then, it will be, I would say, mostly bio-waste or reusing carbon waste to produce this SAF. And after 2035, here we are talking straight, I would say, e-fuel, meaning you take CO2, you combine it with green hydrogen, and you create pure SAF. So you can imagine the volume of project you need to produce this volume of ton of SAF, because usually, I mean, the size of the project is more or less 1 billion for 1 million of ton. So it's a lot, and those projects really make sense when they're close to airport, which means more or less like we are seeing today, the first development. Each airport will have its own unit of production, so it's a lot of projects that will come all over the planet. For the maritime transportation, I would say, like in the aviation, they have more or less no way out of those, I would say, e-fuel or biofuel and syn-fuel, because again, I mean, electrical boats don't really work on this kind of distance, and make them work on hydrogen is not super efficient neither. So it's not really practical. It's better to use e-fuel, to be honest, also, especially on those long distance. The only problem that, unlike aviation, the maritime industry is using different type of fuel. For a long time, they were used to super heavy crude, quite toxic, quite, I would say, high emitters of CO2. And on the last 15 years, they have changed a lot to use LNG or to use lighter fuel to make sure that they could reduce massively those carbon footprint on the ship, to the point that today they are using a big variety of fuel for those ships. And the problem that today, okay, which fuel to use, it's a big question mark. The good part that they have the association, the IMO, which is International Maritime Organization, which is pushing hard for decarbonation with reduction target. And here I put you the two reduction target is to have 5 to 10% by 2030 and 60% by 2030. So here it's quite massive. It's super aggressive, which means that any tankers, for example, that we know very well into our industry, will need either to be revamped by 2040 or either to have to be scrapped, to have a brand new ship by this time. So it's a lot of investment that needs to be made. And of course, when you have all the ships around the planet shifting from one to another, because it's an international regulation, all the shipping companies are today starting to push for projects. And you will see in the list that Jack will present that a lot of those players are coming from this maritime world. Again, the figures are quite more or less the same, which is quite funny in terms of volume. Again, we are talking about 600 million tons per year of e-fuel for just this maritime transportation. So if you combine both, you understand that you are above the billion ton per year, which need to be produced. So it's quite a big volume of e-fuel that needs to be produced. Now, if we look into project design, because of course it's quite easy to say, okay, this is e-diesel, this is biodiesel, and honestly, little people know the difference between both. And already into each category, you may have differentiation, which are quite important to do. If we start by the biofuel, which I would say is sometimes the easiest to get a hand on, today the first generation or the current generation of bio-waste projects we have or biofuel projects we have is recycling bio-waste, meaning that you capture waste from agriculture, farming, or from forests that you're having, and you make a process of transesterification where you are going to split with alcohol the fatty part and the oil part, and you are going to produce a fatty acid methyl ester, which is more or less known under the name of FAME, which is, I would say, a little bit more sexy to be used. And here, usually, you're going to produce biodiesel, for example, which is not really diesel, by the way. It's not the same totally molecule, so that's why it's mixed with diesel. It's not the same molecule. It's not pure diesel. It's quite different than the one diesel we produce from fossil, but it works in your motors, so that's why you can use it. And here, the projects are around 500 million, more or less, and produce 1 million ton per year. Those projects are really well situated around farming area and agriculture area. It's a good way for farmers to value their waste, and we start to see some farms which are making more money from these, I would say, biofuels than from their farming activities, especially in US. So it's quite interesting, but that's quite limited because at some point we don't have enough feedstock, enough waste to produce more biofuel than what we could be doing in the next 5-10 years. So it will have a limitation. So here comes, I would say, the second generation of project, where here it's a kind of a biomass production, meaning that you are going to produce biomass, which is not a waste, okay? It's really the product which is trying to be built is biomass. And here, one of the, I would say, more interesting process I've seen is this one, the HBX biofuel, where in fact you are going to take alga, more or less, that you put in containers which are transparent, and you are going to inject CO2 into those algae to develop the algae as much as possible and use the photosynthesis of the light to produce algae. And then you are going to collect this algae, put them into methanizer, into dryers to transform, I would say, those algae into carbon molecules, sometimes methane straight almost, also injecting hydrogen into those molecules to make sure that you have the biggest, I would say, output. And here you could be producing with 2 billion capex around 10 million tons per year of biofuel, which is completely massive. And the good part is that when you are going to dry those algae, you are going to take, I would say, recover the water and re-inject the water. It works well with seawater as well, so you need less treatment, but it's quite interesting. We see those projects starting to pop up as a demonstrator. So it's not really the same one as you might think with a farm. Okay, those projects are really dedicated to those carbon production. Another process is here the renewable fuel. And here you can use the same feedstock as the first bio-waste. So you can use cooking oil, animal fats, bio-waste, the same feedstock. But here it's not going to be the same reaction. Here you're going to push those waste at high temperature and high pressure with H2. And when you are going to do so, and I hope at least green H2, it's going to break all the carbon molecule and triglycerin to convert them into hydrocarbons. And here it's quite different from the reaction we were talking before, the farm reaction, because here you're going to produce a diesel which is more or less the same molecule as you are going to produce diesel from fossil fuel. So it's the same quality, sometimes even higher quality that you can produce. And here, by using this system, as you're again recycling CO2, you can have a carbon footprint which is even, I would say, smaller, and you can reduce by 80% the carbon footprint of your product. And we start to see it popping up quite massively, especially in US, where for the first time 2 years ago, renewable diesel production was higher than biodiesel. Those projects, they are more or less always the same size because they're depending on the feedstock again, so it has some limitation, I would say. But that's why they're quite well positioned in US, where the farming is quite massive, and the capex is above 1 billion, 1.5 billion, more or less US dollar. And the production, depending on the feedstock, can vary from 3 to 10 million ton per year. So again, you can imagine it's completely massive because it means that if you had I don't know, those big size, 10 million, 60 projects around the planet running, you could power all the plane around the planet. So it gives you latitude of how much potential those projects can have. Of course, the problem that you need the feedstock, you need the hydrogen, and you need the clean electricity, which is today, as you might know, a little bit short for the moment. But when you look at 2050, you may imagine that that could work. Now going to e-fuel, and here the idea is to reuse CO2. As simple as that. So you take your CO2 from industrial usage, as simple as that, and you are going to reuse it one more time. Usually there is a little project when we follow them around the planet which are tagged or labeled as e-fuel, because e-fuel can say a lot of things. People can be confusing. So usually they are tagged as end product. So they are tagged as SAF, Sustainable Aviation Fuel. They are tagged as e-methanol, they are tagged as green methanol. So really the end product is the one which is making the name of the project. And here it's a reaction which is made through a catalyst. Sometimes it's iron, sometimes it's copper, with high pressure and high temperature, and also some injection of steam to produce methanol for e-methanol and water, but also to produce jet fuel. Those projects are slightly smaller, to be honest, because they are high consumer of hydrogen and energy, but you need to have pure CO2. So usually you find those projects close to industrial park, where you know that the CO2, I would say, density in the gas is quite stable, so you can isolate the CO2 and then re-inject it on the ground. But anyway, the volume of production is quite massive because those molecules are quite heavy, and you can end up with quite easily 100,000 tons per year of production. And again, those projects, they pop up all around industrial complexes and airport, either because you have the feedstock CO2, either because you have the need for the usage of this SAF. So it's quite interesting, and you see some companies which are becoming expert on those projects and becoming kind of licensor for them. And last but not least are the Syn-fuel. And here, Syn-fuel, we find not so many projects, and we find them in countries with high reserves of coal, okay? Because coal, as you may know, to use emits a lot of CO2. So people are not so keen into using coal straight away. So the idea of Syn-fuel processes is to reuse this coal, and you are kind of going to bake it in a way or another, because the first step of using this coal to produce gas and gasoline, or also to be used in fertilizer, is to make a gasification process by injecting steam and oxygen at high temperature, around 1000 degrees, to make sure that you're going to cook this carbon, and you're going to make a reduction of the carbon molecule. And from coal, you can, I would say, at the output have gasoline and heavy oil. That's where you will hear all the day about this Fischer-Tropsch method, where you're going to inject fer and sodium to make this gasification through compressors. It's quite a tough method, but it was invented in Germany to produce gasoline from coal in the last centuries. Usually those factories are quite massive in size. They are quite well known in terms of process, but to be, I would say, competitive in price, you need to have a big size for it. And you need to have, of course, coal, which is ready and cheap close by. So it's a big capex, but it's also big volume of production with good quality. So that's why countries like China, India, or Indonesia are quite keen into using those projects. You can also find them, some of them in Germany and in Australia. Not sure if they will still open more of those projects, but it's still quite interesting to follow through. Now passing the ball to Jack, which we will have a look on, I would say, the business side of those projects.
Thanks, Jean. Thanks for this explanation. I saw in parallel that it already triggered some discussions, everything that you said. So we'll have a lot of Q&As, I guess. But first, let's have a look of, let's say, everything you say. How does that translate into projects? Because alternative fuels are not exclusive to the rest. There is a lot of announcement, and the reality is sometimes a bit different, but a lot is happening. And if you look at the graph below, basically before COVID, that was very marginal, almost non-existing, to suddenly exploding and doubling every year. So that's That's the forecast. We intend to reach something like about 25 billion. So going from 0 to 25 billion is quite massive. And the forecast even after that is already quite heavy, translating that up to this will not fade away in the coming years. And if we look only at the what has been awarded, so the actual figures, the pattern is the same. We are already above the 15 billion being awarded, which is already today, and there is basically a third of the year still to go, and we are already way above what has been awarded full year 2023. So it's actually growing quite fast. But alternative fuels, and you will see later in the slide, also calls for the same actors, meaning that there is still a bottleneck in the supply chain, and they are facing it. So a part will be still potentially awarded before the end of the year, but a part will have to be postponed to 25 and 6 and 7 for the rest of the projects. So for that, they are, let's say, treated like the rest of the projects. But if we look at the footprint here, good to have the numbers, even if the result is not a big surprise per se, meaning that this market is being led by North America, so US and Europe. This is also where there is a lot of, let's say, governmental support, which help these projects to grow very fast. I mean, US and Europe, they are doing 75% of the business. That's where the projects are. But this is also where the projects are being designed and executed. So what will most probably happen with what John said, that it will be exported from Europe and US. So it could be very interesting from a strategy point of view to be involved today in these projects. So when they go to export, you're part of the luggages. Two things also that we can see or don't see. The first one is the absence of a Middle East. It's almost not existing on this market yet. But we know, as John mentioned, that when they start investing, they are not shy. So when they will go on these projects, they will catch up quite really fast. And on the opposite, we have South America, so not at the size of Europe, of course, but still their footprint, their weight is around 11%, which is quite huge. If you look at their weight on the global energy market, it's more around 6 to 7%. So they are quite active in these alternative fuel projects. And this is where also we had a lot of pioneers projects over there, thinking about Porsche in Chile a few years ago. Now, if we start to look at the key players, we will look at two ways of that. First, the operators, and then engineering company. If you attended our last webinar on independent operators, you're not surprised to see them as leaders of this project. Yet they are dominating by head and shoulders. They're taking more than 80% of the market. That's the first outcome. And the second thing is that the diversity of operators is quite impressive. Currently, we have 101 active projects, okay, because not considering again the political enhancement, that's for business, but on these 101 projects, there are 86 different operators, meaning that most of them, they only do one project. Some of them, few of them, two, and even less are doing three, but that's it so far. So that's a quite interesting fact. And most of them, or several of them, were not existing before COVID, and the older ones, they are from 2010, 2015, when really this alternative fuel started to grow. If you look at the list, and we rank them by capex, so that's the 20 big players, let's say. As you can see, most of them are independent. Some names may be completely unknown to you. There is the absence of the historical independence also, that is quite striking on that list. But you still can see some historical oil and gas company. Here in the list, you have Shell and BP among the top 20. But if you extend that list within Project Smart Explorer, you will be able also to see Eni, Chevron, Equinor, that are also taking that turn. Just not yet as fast or as big as some independent operators. If we look at the engineering, the story is a bit different here. We rank by the number of active projects they have, and all the names, you all know them. I mean, it's Honeywell, it's Technip, it's KBR, it's Linde, it's Fluor. All these names that we know because of the proximity with their technology. So this is a good sign for you. The other, let's say, profile that we see, it's actually the operators themselves doing the feed for their own usage, like Sungas, Renewables, or Sky Energy are doing. As we want to have a bit of time for the Q&A, I suggest that we jump now to the conclusion. Jean, maybe before actually taking the first questions.
Thank you, Jack. So going to the conclusion, then we jump on your questions. So feel free to start to ask them. We have Jean-Charles today, so if we have tough questions, we'll pass them to him. But just the few key points of today, that clearly alternative fuel, e-fuel, and all those fuels are crucial tool for decarbonation. I mean, it's impossible to think that we could decarbonate everything and make everything, I would say, electrical. Clearly, it's not the case. So those fuels will have, I would say, a role to play into this decarbonation and energy transition. And the good part is that they are easily adaptable to our energy system as of we have it today, to our usage of energy. So usually they are quite well accepted, a little bit better than changing the solution. So people are quite keen into paying more for those solutions. Also, there are clearly the solution for, I would say, sector like aviation or maritime fuel, where there is no really other way out. Okay, there is not better solution than using the carbon molecule for this energy. The challenge is really how to stop the emission. So as we try to explain, those processes are quite new, highly specific. I mean, if you are familiar with the petrochem, it's nothing completely new. Those processes, we have known them for quite a time. It's just that today the size and the number of projects using those processes is increasing. And of course, if you have a solution for any type of those processes, you should go for it because it will be a pop-up everywhere. Those projects, they rarely, in large size. Usually, they are going to remain into the size of 1 billion, 2 billion. So not small, but quite medium, let's say, because they are depending either on the feedstock or on the user, which is close by. So it means that you cannot have, I would say, a home place of E or SAF production. Maybe I would say after 35, when maybe I expect some Middle East country to start to have a look onto those projects and those applications, and will of course go big to try to impose a global market for those fuel. But in the meantime, it means that the design will be known. And of course, if you start to design an e-fuel factory in Germany, in US, you can take the exact same design and do it in Saudi Arabia. So it's quite a good time to jump on those projects, because it means that then you can go to the export with your engineering companies doing it. In terms of operators, you see it's completely new players, a lot of names that you may have not known, which are coming sometimes also from the usage. You have seen Maersk, which is one ship owner, but Air France is starting to invest into those projects as well. So you see, it's brand new names which are not super used to this kind of project. And of course, if you start to approach those companies, you will have little to no competition, more or less, because they don't have vendor list to play with and to go around. So already, if they have your support, they will be more than happy to do it. Knowing that the engineering companies, for many of them, you know them. You see the top is Honeywell, so it's really licensed source companies. And if you cover all the US and European, meaning Western contractors, you are covering more or less 2/3 to 3/4 of the market. And the idea is, of course, to place your product into this license, because the license business, if you're in, it's great. If you're out, it's really tough. So it's better to be at the start, make some effort and investment to jump on those license. And of course, it will drive some business for you on the coming years. The good part is that the pipeline of projects is quite lean, it's quite steady. If you compare it to other branch of energy transition like renewable or hydrogen, where the projects are happening but not really happening, here it's quite lean because you already have the market. Okay, you have companies, airlines, which have already, I would say, their forecasts of rules for decarbonation, and they know that they have no really way out of this. So they could backtrack a little bit those targets to know, okay, at this date we need this volume, at this date we need those volume. And as they are, I would say, industrial clients, they are quite, I would say, safe to bid on, which might not be the case if you are bidding just on I would say, governmental contracts. So it's quite interesting. It's developing lean. Okay, it's not a boom from 0 to 1. Okay, it's going steadily. I mean, we are talking about something which was zero more or less 5 years ago, which today I developed to the size of 15 billions. So it's clearly not the size that we find in renewable, into hydrogen, etc. The market is way smaller, but developing quite well. So of course, if you have solution for this market and you want, I would say, to transfer, from petrochem to those applications, we can encourage you and provide you the information to do so.